Hello, Calculus 2 students, and welcome to another math review. Here we're trying to find the volume of a solid bounded by y equals x squared plus 1, y equals 0, and x equals 1, and while rotated about the y-axis. First thing we need to do is graph these functions on a Cartesian plane so that we can visualize this problem better. We do this by plotting the x and y coordinates of the first y function that we're given. So when we plug in -1, we would get 2. When we plug in 1, we would get 2. And when we plug in 0, we will get 1. So if we plot these points here, we'll get a positive parabola. And if we insert the x equals 1 limit, the asymptote there, and the y equals 0 asymptote, we now have to determine whether we will be using the shell, disk, or washer method to solve for the area of this figure. It's probably best to use the shell method for this figure because this looks like a cylinder when it's drawn out. So the formula for the shell method would be 2 pi radius times height for its area. We'll get to volume in a minute. So we have 2 pi. The radius has to be a function of the x coordinate as it's traveling up to 1. So our radius is going to be a function of whatever x is at any given point within this figure. So the radius is going to be x. Height, on the other hand, is going to be a function of the curve as it's going across about the x-axis. So as it's going across the x-axis. So we're actually given the y function here. So the height would actually be x squared plus 1. Now that we found the area, we could find the volume of this figure. So the volume would be 2 pi integral of x times x squared plus 1 dx. First thing we need to do to simplify this is to plug in the x into the other equation. So then we would get x third plus x dx. Second thing we need to do is separate these two x's from each other. So then we would get 2 pi while we integrate at the same time. So we would get 2 pi times x to the 4th over 4 plus x squared over 2. With our limits being y equals 0 as the bottom limit and x equals to 1 as our upper limit. So for going from 0 to 1. Now we need to plug in our limits into this equation, which would give us 2 pi times 1 over 4 plus 1 over 2, and the rest would be 0, so that won't count. So now we have, to simplify this further, 2 pi over 3/4. Simplified further, we have 6 pi over 4. Simplified even further, we have 3 pi over 2. And that is how you solve for this integral.